Hi, it's time for another math easy solution. Today we're discuss we're gonna go continue on the power function. We're gonna discuss x to the power of 0 and 0 to 0 and what they are. Well, you know that from my previous video I showed the definition x is supposed to equal to 1, and 0 to 0. This one is tricky. This one is actually it can be it's undefined. I'll show you why, but you can also set it equal to 0, but you can also can define it equal to 1 for certain cases. Well, if you look at this one, let's look at a graph of, let's say, 3 to the x. Let's say this is f of x. If we were to graph it out, let's say, well, yeah, if we graph it out, this is y equals f of x, and this is x. So the critical point, let's say -1 and 1. If we were to put, let's say, negative infinity in here, let's go 3, let's write it down here. Let's say we have 3 to the negative infinity, or this all the way over here. As you can see here, at negative infinity, this one is this would be basically equal to 3, well, infinity over 1 is the negative from the previous video, you could see. And this basically goes to 0. So it goes to 0 because 1 divided by 3 to infinity is just basically infinity. Infinity again, and then this just becomes 0. So it is approaching 0. So as you see, it's approaching 0. And it kind of curves up. And then at -1, 3 to the -1 is just equal to, well, 1 over 3 to the 1. That's just 0.333. So this would be, let's say, 0.3, and then that. Yeah, so this equals to 0.3, and it keeps going on, or 3, 3, etc. Okay. And so then it will get to here. And this is the tricky part in between here, but at 1, when 3 goes to 1, and you know this is just 3 times, yeah, it just equals to 3. That's just how the definition is. So then this would just be 3. So here. And then at infinity, let's say positive infinity. Let's go to, this is at plus infinity. You'll have 3 to the infinity, and this is just, again, approaches infinity, but at a fast rate. So then this just goes to infinity again. So what you'll have is basically like this. It's going up, and this is to infinity. Yeah. So infinity up as this approaches infinity. So you can see this is going to 0, and this is going to infinity as it goes there. So now what we want to see is in between this. Alright, so in between this, let's say let's go to between 1 and 0. So let's go write this down. Between 0 and 1. Okay, so we'll just look at cases here. Let's actually look at, let's say, 0.5. X equals 0.5. This is then you'll have 3 over 1 over 2. That's just 0.5. And this is basically a number times itself. So then this will just be, let's say, a times a equals 3. So that's what we're looking for. And then basically this would be, well, it has to be greater than 1. Because 1 times 1 equals 1, and 2 times 2 equals 4. So that's be in between 1 and 2. So a is in between 2 and 1, and well, I'll just put this calculator here. I'll just grab this out. So then this one would be, let's go Google search, and let's go with 3 to the power of 0.5. So 1.73. Okay. So then this would just be equal to 1.73. And if we were to graph this point, let's go 1, 2, it's roughly, this is 0.5, and this is roughly 1.73 here. It's not the scale, but doesn't matter. And if you put 0.75, we'll just go 3 to the 0.75. That's x. This would just be equals 3 over 3 over 4. I'll just delete this. Okay, so 3 over 4. Then this would, if you use that other property, so this would just be 3 over 3 and 1 over 4. And this would be 27. 3 times 3 times 3 is 27. 1, 4. And then if you see the rules again, this would be just a times a times a times a has to equal to 27. So this is, so what a would be, well, it can't be 2 times 2 times 2 is 16. We go 2 times 2 times 2 times 2 equals 16. And 3 times 3 times 3 is just going to be 81. If you have 3 times 3, 3 times 3 equals 81. So it has to be, a is between 3 and 16, 3 and 2. And it's going to be closer on the 2 side, so probably 2.1 or something. So if we put in the calculator, we'll get 2.27. So then this would just be 2.27. And then if you plot this out, this is approaching here. And it actually curves to there. So this is a better curve there. And then now if you were to, if you were to look closer, let's go to closer to 0. Let's go 3 over 110. So this by definition is basically a number, a times a times a. That's the number we want. Well, this is not equal. This is, say, that's what we're looking for, a, all the way to 10 a's or whatever, 10 a's. So basically, let's say it can't be 2. 2 times 2 times 2 times 2 is all the way to 10 is going to be really big. So it can't be, let's say if it's 1, 1 times 1 times 1 all the way, it's going to equal to 1. So it's going to be greater than 1, less than 2. So it's going to be closer to 1. So we put in a calculator. We'll go 3 to the 1 over 10. So that's 1.116. So then this equals 1.116. So this, let's just get it closer here. And this is, just say, 1/10. And it's close to it. And it's actually curves like this. It's going to be continuous. And then if we were to, let's say, 3 over 100. So again, we're looking at a number times itself 100 times. So if we put in a calculator, we'll just put it in. So it's 1.01. So as you can see, it keeps getting smaller, but it's getting closer to 1. It has to be always greater than 1. Because we know that 1 times 1 times 1 is going to be, all the way, it's going to be equal to 1. Yeah, so it has to be closer to 1, but the limit, if we were to go 3 to the 1 infinity, then this will have 1 times 1, well, not 1, we'll just erase this. Yeah, so this would be a times a times a, and all the way to infinity. And what you can see, it gets smaller and smaller and smaller. So it actually, the limit, it goes to 0. It goes to 1, I mean. So then basically, 3 to the 1 infinity. It's this is limit. We'll just erase this. Okay. Alright, yeah, so if we were to go back to the graph, so as you can see, it will reach 1. And if you put, let's say, negative 0.5, so we'll go here, we'll look at this right here, 0.5 negative. So you have negative 0.5, 3 to negative 2, this just equals to 1 over 3 over root 2. And we found this one out, it's going to be 1.73. So then it's going to be equal to 1 over 1.73, and this is going to be less than 1, and it's going to be around somewhere between this curve. So yeah, you can see that based on the definition of power functions, it doesn't really correlate to this, because you'll have, let's say, 3 to the a, or 3, yeah, this just means you'll have, I'll just erase that. Yeah, so we'll just put it actually 3 to the 2. So this is just saying a times a equals to 3, and a is equal to 3 over 2. So that's the definition of it. And you can see that it has to be greater than 1, but then the problem with 3 over 0, yeah, and then see this one you have to define it based on the limit, because we can't really use it, because 0 doesn't really make any sense. How could you have 3 times, or a number times a number to 0 times? So this is basically the definition. Basically, it doesn't really make physical sense. You just have to look at it based on how the graph looks. And if you were to graph it, we'll just graph it here. You can actually just write, let's go 3 to the x. Oh, whoops. 3 to the x. Yeah, as you can see, this is, yeah. So as you can see, this one, if we were to zoom in, it basically looks exactly like we want it to. I'm just zooming in. I'll just make this bigger. Drag it here, zooming in the x. And let's just zoom in. I'm just scrolling my wheel. So if you keep zooming in, zoom out a bit. Yeah, so you can see x1 is 3, and then it goes down. So basically, yeah, it's defined basically by the limit. So that's how it is. And now the tricky one is actually 0 to the 0. This one is actually, wait just one sec, I got a phone call. And so if you look at this one, 0 to 0, let's just look at 0 to x. This function equals fx. If you look at this, if you go for x is greater than 0, you'll just have, let's say, 0 to 2. So you'll just have a number times a number has to equal to 0, and that's going to be 0. So you can see for x is this one, you'll have equals 0. But if it's for negative, let's say x is less than 0, then you're just going to have basically, let's say, 0 to negative 2. This equals to 1 over 0 to 2. And this is 0, so you just have 1 over 0, which is infinity or undefined. So if you were to graph this, you'll just have, well, I'll just make a straight line. This is that's x. It's good enough, x, and this is y. So if you graph it, this one's going to be 0 for everything. This is, let's say, a circle here. That's at 0. This is x equals 0. Yeah, so this is basically 0 always, and then it's undefined. This is x equals 0. Undefined or infinity. So you basically that's how the graph would look like. And so basically 0, 0 is undefined, except sometimes they use you could have 0, 0 equals 1 by definition. So this is just by definition. You could have this. You could have this by definition, and it's case by case. Meaning, if you're deriving a function or whatnot, some people actually argue that you could use this better, because for some functions, so if you have like an equation like this, instead of having to separate for 0, 0, you could just include it in there. So you have a function like f of x, y. So this just all depends on the case by case and the calculator you're using or the program. So if you were to go to Google, my graphing calculator actually goes 0, 0 equals undefined. But if you go 0 to 0, this equals 1. So this is just on its definition. So it's case by case definition. Well, hopefully you learned about 0, 0 and basically x to the 0, and y x to the 0 is equal to 1. Just the limit is approaching there. So that's what you could. So it's basically derived by the limit. Well, hopefully you enjoyed and learned a lot, and tune in next time for another math easy solution.